What's up guys, it's Kevin, Midnight Garage here. So today I'm going to do a video in response to a question on the 10th gen F150 questions any and all page on Facebook. And this user, Abraham Abundus, apologize if I butchered your name, is having some issues with air conditioning. He says he called it quits, put the truck back together, AC held vacuum for an hour and stayed in vacuum for 45 minutes. He recharged with a pound of Freon. The other pound is going to charge with the AC clutch kicking on and off, but the clutch is never engaging. So I wanted to take a second to make a video to kind of help answer the question. And we're going to look at the wiring diagrams for the air conditioning system and see if we can't lend some advice so that maybe he can get his air conditioning up and running. Okay, so here I have all data up and running for a 1997 Ford F150 two-wheel drive pickup with the 4.6. There's a VIN W and a VIN 6 option, but I don't see that really having any bearing on what we're looking up here. Okay, so let's go to heating and air conditioning, and we're gonna look at the OE electrical diagrams with AC. Okay, so here is the diagram for like the blower motor resistor, the function selector switch, things like that. If you need to take a look at this because you have a 10th gen who has some issues, go ahead and pause the video so you can take a look at this. And here we're getting to blend door actuators, function selectors, and our AC compressor clutch solenoid. Okay, so just talking about how we read wiring diagrams, right? Power starts at the top and runs to the bottom. So the bottom will see grounds, and the power is going to start from the top. Okay, this fuse in the junction box, fuse relay panel, it's a 15 amp fuse, is sending power when the key is in run, and it's sending power down through this line, a light blue and pink wire, into the function selector switch. And this is what's going to move all your blend doors and trigger your AC to come on right here. Now the power comes into the switch and it travels along these lines. So this is only going to continue to send power, the little arm, when it touches AC, max AC, panel or floor defrost and defrost. That is you're gonna have air conditioning during those modes. Panel and floor do not necessarily trigger the AC clutch. Okay, one thing, just a little tidbit of information: if your AC is not working during the winter time and your windshield fogs up, your defrost is not going to work correctly, for those who may not know. Okay, so power is coming in from this fuse, right? And we are expecting 12 volts of power, because if we look down here, when it goes into a blend door actuator, it says 12 volts run. So this is a 12 volt circuit. Okay, this is a splice. So 12 volts comes into the function selector switch. He has it on AC or max AC. Power is going through here, boom, jumping over to here and coming down. AC pressure cutoff switch, normally open at or above 445 psi. and closed at or below 260 psi. Okay, so this switch, when the system is charged adequately, is going to be closed so that power can continue to flow down here. And again, remember, we're still looking at 12 volts of power. It's going to travel down from a pink wire to a red and yellow wire to the AC clutch cycling pressure switch. So this would be like the high pressure cutoff switch. This would be a low pressure cutoff switch. It's normally open at or below 24.5 psi and closed at or above 43.5 psi. Used to adjust the electronic pressure control. It's the cylinder in the transmission. Okay, so you have to have the system charged properly so that these switches have the appropriate PSI so that they can operate. Charging with just 1 pound of refrigerant may not give 43 PSI, or it may not even be 24 PSI. It might be like 10 or so. You know, it really just depends. And this is also why I made a comment on the post that charging the system with manifold gauges and a vacuum pump, albeit possible, is not the most ideal way to do it. It's great. It's the best to use an R134 machine because the machine will put it at a vacuum. It'll verify there's no leaks, and it will charge the system completely. And if for whatever reason the charge pressure drops, it will repressurize the cylinder and continue to push refrigerant in. When you're doing it manifold gauge style, if you don't have the cylinder sitting on a scale, you don't actually know how much refrigerant is going in. Like I said, it's possible, but it is definitely not the best way to get it done. And if you're having issues with your AC, that is going to be a variable. Okay? So power comes through here. This switch will close at or above 43.5 psi and allow power to come down through this black and yellow wire. One goes to the engine computer, PCM, and then another branch comes off to the AC clutch diode and the compressor clutch solenoid. So once this switch closes, you're going to get 12 volts to the AC compressor clutch solenoid, which is the grayish rectangular connector just behind the pulley. As if my memory serves me right. That's what it looks like. Connector 106, it's a black and yellow wire. You should have 12 volts power going to that connection. And then on the other side, since this solenoid has used up all the energy, you expect to see 0 volts on the ground side, the black wire. This diode is here just to catch ripple in the system when the solenoid engages and disengages. Okay. Electricity is going to take the path of least resistance. Okay. So is it possible that this diode has failed or has shorted and electricity is able to just go this way with a small bit of resistance? Yeah, it's possible. I would expect this fuse to have blown as soon as this pressure switch closes. But it's a possibility. It's also something to check out. But me personally, I have not ran into that situation very often. But it is a possibility. So you were testing and probing different areas, having your black lead of your multimeter on ground, a good ground, and using your red lead to probe this connection at the compressor. When you go in the truck, put it in run, and you have the function selector switch to AC or max AC with it running so that pressure can build up and these switches can be closed. You expect to see 12 volts here. Okay. If your selector switch is off, you expect to see 12 volts here and 0 volts here, all down here. If you move the selector switch to AC or max AC and you go to this AC pressure cutoff switch and you probe it on the pink wire, you're expecting to see 12 volts. If you go to the other cycling switch, engine running, AC on, if you probe the connector, not the switch, the connector, red and yellow wire, you expect to see 12 volts. If you do all of that and you come down here to the, well, this would be an inline connection, connector 120, male, female. If you were to probe it here, engine running, fully charged, AC or max AC, you should see 12 volts. Okay? Everything you're looking for is 12 volts. Now, if you don't get 12 volts, and I think in your post, if I remember correctly, I put leads to compressor AC clutch connector reading 0.014 volts, and from low pressure switch harness shows 12 volts. Okay, so low pressure switch harness shows 12 volts, which you have, which would be connector 139 right here, 12 volts. Okay, so I guess electric issue from the switch to AC clutch because I bought a new low pressure switch and high pressure switch. So you tested it here and you got 0.014 volts. You tested it here and you got 12 volts. So I am testing the black and yellow wire on this side and here, unplugged, switch unplugged, compressor unplugged. Switch your multimeter to ohms resistance and test the resistance of this wire because you want to see if there's a bad splice. You want to see if this connector is messed up, corroded, not plugged in all the way, or whatever have you, or there's a break in the wire. If you do not get if you do not get a reading close to 0 or less than half an ohm, 0.5 ohm or less, roughly, if it's 0.6 ohms, 0.7 ohms, it's all right. 0.5 or low is best. But if you get anything that is higher than an ohm, 1 ohm, workshop manual or service information says like 5 ohms or something like that. Basically, you want the number to be as close to 0 as possible. If that is the case, then you have continuity throughout this line. Okay? What you could do is do a voltage drop test to see the voltage from here to here. So you would be putting your multimeter in voltage, in volts, everything connected, red lead here, black lead here, and see what the drop in voltage is. Ideally, it would be close to 0. That means that no voltage is being wasted here. If it shows 12 volts, then there is a break or there is extreme resistance or something is not happy in this line. Okay? Since you got 0.014 volts at this location, from what I'm seeing, power is not making it from here to here. Okay? Double check this connection. Connector 120M120F, which I don't think is going to show me, but let's try. Usually, older vehicles, they omit the connectors. So we'll see if they have it available. So diagrams, let's go back here. Vehicle, diagrams, electrical OE. connectors. That's what I was looking for. Okay, so we're looking for C120M and F. C120. C120 is the right rear of engine compartment. Well, they don't really give us a picture. It's an old vehicle. Right rear of engine compartment. Right rear of engine compartment. That might be the connectors up by the battery area, the receiver dryer, like up at the firewall there, is where I'm going to wage my bets. Is where that is. I really wish they would give me a hyperlink, but like I said, vehicles this old, they really don't keep a lot of this stuff in old data. Mitchell or Identifix might have had it, but right rear of engine compartment, connector 120. Okay. So I hope this was helpful for you. Some things to try, some wires, colors of the wires, explanation as to what's going on, how the power flows. Hopefully I answered some questions for you. And if you have any other questions, let me know. For anyone else who has a 10th gen F-150, if you have any questions, let me know. And I'll do my best to make a video of it for you guys and answer any questions that I have. So yeah, thanks for the video. Thanks for being here. And it's been fun.